this is an example. We're going to first find the first derivative, and that would be 8x to the third minus 9x squared, and then plus 12x. You have to set this equal to 0. Now factor if you can. It looks like we can take out an x and be left with 8x squared minus 9x and then plus 12. Now of course setting this one equal to 0 is just 0. And then 8x squared minus 9x plus 12 equals 0. You can use your calculator program for that. I still have Blankenship's program in my calculator. For some reason mine's gone. So the A value is 8, the B value is -9, and the C value is 12. What happens to that? Yes, it is a non-real answer. NRA, not the National Rifle Association. It's a non-real answer. So if it's a non-real answer, what you can do is what's coming up next. So here's the graph of 2x to the fourth minus 3x to the third plus 6x squared. Now it's always a good idea to zoom out. Of course I can pinch and zoom. On your calculator you have to press the buttons. But this one looks like it just has a minimum down at the bottom. And when you go there, here's how my trace works. I tap the graph, and then you'll see, or maybe not, a gray circle that shows up at 0, 0. You tap that, and that means that's a critical point. Once I tap this, all the critical points show up. So since it's positive, it goes up like this. Or actually, I'm using my hands, and when I have a pen and I'm recording in front of me, it goes up like this because it is positive, and you have no other maxes or mins in here. So 0, 0 would be a minimum on that. On your trace on this, notice when I tap and hold it, the trace follows along. If I had a, is it showing up for you? Yeah, there it is. Then you could find a point of inflection, which of course this one doesn't have one. But you could follow along until you figure out where it's at. That's just in a rare case.